The first three, I think, are dilation questions. And that is probably the furthest back. Like that was toward the beginning of the unit. So it's not as fresh on your mind, probably, unless you were working on the review recently. But the basic dilations, we talked about scale factor in 5.1. If you have a scale factor, that is your multiplier. You are just multiplying by that number. If it's a side length, you're just increasing the side length by that much. Or if the scale factor is less than 1, it's reducing by that much. In y'all, your scale factor, I don't know, it may have been, if it's greater than 1, it's enlarging. If it's less than 1, it's reducing, right? And instead of a shape, they're giving you a point, a coordinate. And they want to know what are the new coordinates after the dilation. So this is straightforward because it says centered at the origin. When it's centered at the origin, there's nothing special or tricky or anything about it. Yeah. You simply multiply by the scale factor. So in this example, in this one that popped up for me, the point's at -4, -4. We're scaling by 5. So we just multiply those. So that should be -20, -20. Now yours, obviously not everybody's question is the same. This is from the Delta Math question bank, so everybody's was slightly different, but it was the same concept. Okay, you just take your X and your Y and you multiply them by your scale factor. If your scale factor is a fraction, you multiply them by that fraction. And y'all get the scientific Desmos on the test. So like the multiplication, you'll have a calculator for. You don't always have to do that in your head. Questions on just basic scale factor dilation? All right, the second one, also basic dilation, but this time it's with a shape on the coordinate grid. We've got this polygon here, and they want us to dilate it by a factor of 3, and again, centered at the origin. So that means it's not tricky, it's nothing special, it's just basic scale factor of 3. Okay, we're going to multiply everything by 3. So you can start with whatever point you want to, whichever vertex. You have to replot all of them. Okay, so I'll start with C down here. Okay, so C is at 2, -3, and my scale factor is 3. So I'm multiplying both the X and the Y by 3. So 2 times 3 is 6, and -3 times 3 is -9. So there's my new C prime. Okay, and then B is at -0, -3. Well, 0 times 3 is still 0, and -3 times 3 is -9. So there's my new B. Okay, so there's the new C prime, B prime part of this figure. Okay, F is up here at -2, 2. So -2 times 3 is -6. And 2 times 3 is +6. So there's F prime. Okay, E is at -1, 2. So -1 times 3 is -3, and 2 times 3 is 6. So there's that one. And you have to just plot the 2 points to connect them. So you can go ahead and connect those if you want to. Okay, now D. D is at 1, 0. So 1 times 3 is 3, and 0 times 3 is still 0. So it's going to be here. I'll go ahead and connect it there. Okay, and then I just need to connect my D to C. So I replotted the new image based on this pre-image. Okay, and that's all it is. You're multiplying all of your X's and Y's by whatever your scale factor is. So, and it even shows you when you finish it, see how it increases. It dilated. It kept it proportional and just increased the size. We feel okay about that type? Now 3 is one that I added in. This was a teacher created dilation one because Delta Math didn't have one where the center of dilation wasn't the origin. And we learned in 5.2 this process of dilation that's not centered at the origin. Okay, I showed y'all a algebraic option and a graphing option. Okay, I went ahead and opened up those notes to remind you when we're doing the algebraic process, okay, you can come up with your formula. You're essentially taking your X and Y and doing the opposite of whatever that center of dilation is, because you're moving it back to the origin, and then you scale it by whatever your scale factor is, and then you move it back to the center of dilation. Okay, so if you don't remember this, you may want to pop out these 5.2 notes or pull them up on your computer in Canvas. I have 3 examples showing this algebraic process. Okay, and then on the back, it's those same 3 examples, but it's showing the graphing process. And I think it was like 90 or 95% of y'all, when we did this, I asked like, how many of y'all prefer algebraic? How many prefer graphing? And like the great majority of y'all preferred the graphing method. So these were the steps for graphing. You would have your center of dilation on your graph, okay, and then whatever point it is. On our practice, we did polygons. This question on the quiz is just 1 point. You're only having to do it 1 time, okay? But you take your center of dilation and your original point, and you count the vertical and horizontal distance between them. So that's step 1. Then you scale those distances. So whatever your scale factor is, multiply by that. Then you count that new distance from the center of dilation. Some people are making the mistake and counting from the original point. It has to be from the center of dilation. So I'm going to show you this one from the quiz, graphing, because that's what the great majority of y'all preferred when we learned this originally. They don't give you a graph. They don't plot the points for you. So you have to plot them. You do not get graphing Desmos on the test. You would have to actually plot it on your grid paper. I offered you scratch paper, graph paper during the quiz. I'll offer you it during the test as well if you want to have graph paper to do your scratch work on. Okay, but I would plot the point X and the center of dilation, okay, to start. Now, because I'm doing this for you on a screen, I'm going to show you, bless you, with Desmos, but just so you have a picture, but you would have to do this on paper. You would plot these points on paper so that you could see them. Okay, so this is going to be point X, and then my center of dilation was at 2, 5. And I'm going to label that as COD for center of dilation. Okay, so what you're looking at, okay, here's my center of dilation. Here's the original point X. So I want to dilate this point X around this center by, what was the scale factor? 1/3. Okay, so the process is to count the vertical and horizontal distance between the points right now. So from my center of dilation, I would have to go down. That goes to -7, so that's 12. Okay, so my vertical distance is 12, and my horizontal distance, that's at 2, is 15. So that's my vertical distance and horizontal distance. Now I scale those distances. My scale factor is 1/3. So you can think of this as times 1/3, like this. Or multiplying by 1/3 is the same thing as dividing by 3, isn't it? So you can do it as dividing by 3 or multiplying by 1/3. It doesn't matter. But these are the new distances. So the vertical distance is 4 and the horizontal is 5. From the center of dilation. Don't come to X and try to count those. From the center of dilation, and it has to be in the same direction. It was down and right, so I have to go down and right. So I'm going to go down 4 and right 5. So where does that put me? Would this point be? 7, 1. So I would come back here and say, okay, that new X prime would be at 7, 1. Does that make sense? 5.2. Get out your 5.2 notes if you're struggling with that when you're doing your corrections. There's also questions like that on the review. Those of you who did the review, or maybe didn't finish, but started the review ahead of time before the quiz, probably did better than those who didn't, because you've seen some of these types of questions in the review as well. It hadn't been so long since we did the practice. Okay, so those were the 3 dilation questions having to do with, like scale factor and dilation. In my last class, I already made a video, so there's a separate video going over the other teacher-created problems, which were 4, 14, and then I went over 16 and 17. Those were the geometric mean questions, and 20. Okay, so are there any others that y'all want to go over? Any of that I can help you with? 4? I'm gonna look at 4 again. Okay. All right, so this one, I think I already have it worked out here with a picture. Yeah, so if they don't give you all the markings and everything on the picture, draw it on your scratch paper. So draw that triangle U and C, okay? And then they tell you B is the midpoint, so I add point B, it's the middle of U and N. G is the midpoint of NC, so I add point G in the middle of N and C. So when you connect BG, which is what they're asking about, so you have to make that connection. What type of segment is this? A mid-segment. We learned this back in Unit 4. A mid-segment connects midpoint to midpoint. And you need to remember that a mid-segment is half the length of the side that of the triangle that it's parallel to. So they told you UC is 16. So we know that BG must be 8 in the pre-image. They tell you it's dilated by a scale factor of 2.5, and they want to know what the image of BG will be. So the 8 is the pre-image. So you have to multiply it by the scale factor, and that gives you 20. Or you could have taken 16 and multiplied by the scale factor, and then taken half of that. So you either take half, then multiply, or multiply, then take half. Either way, you get 20. Does that make sense? Okay. Any others that y'all want to look at that y'all were kind of stuck on or couldn't remember what you were supposed to do? Maybe just the wording was confusing. All right, now? Yeah. 12. All right, so number 12 was one of the conjoined triangles where it's like a bow tie situation here. We've got these lines intersecting. So P is a vertex of both of the triangles. Okay, now they tell us in this diagram all this information. It's not labeled, so my suggestion to you is always to draw it, label it. So I'm going to copy it over here so I can draw on it. And you would do this on your scratch paper. All right, so I'm going to add all of this information. They tell us that QR is parallel to NO. And they tell us that QR is 30. PO is 28. PR is 20. Find the length of NO. All right, so before I do anything, I need to confirm that these are similar triangles, okay? Because it says not necessarily drawn to scale. the fact that they told us that these are parallel tells us what we need to know. Because if we have parallel lines in a transversal, alternate interior angles are congruent, aren't they? And then here in the middle, vertical angles are congruent, aren't they? Y'all see that? So I've got enough information to know that these are indeed similar triangles by angle-angle similarity theorem. Okay, so I'm going to write out the similarity statement because that helps you organize which vertex or which angle goes to which. So in this top triangle, if I name it QRP, Q had no marking. Which angle here has no marking? In this triangle, which angle did I not put a mark in? N. So I would have to start with N. That means Q corresponds to N. Okay, and then I went to R. R has one arc, like O. So O would be the next one, and then P. So that helps you to visualize which sides correspond. So when I'm setting up my proportion to solve for the missing side, I know that RQ corresponds to NO. So when I set up my ratio, that's what I'm looking for. I'm going to call it X. I can say 30 is to X as, now I have to pick other two sides that correspond. So looking at what I know here, I know RP is 20. That's going to correspond to OP, isn't it? And OP is 28. So I did the 30 on top, so I have to do the 20 on top. And then I cross multiply and divide. So 30 times 28 divided by 20 is 42. And I go back and I double check. Is that what they're asking for? Find the length of NO. That's what I was looking for. Does that make sense? It didn't tell you you had to write this similarity statement, but that is helpful to so you can see which letters correspond to which in between the two triangles so that you get your proportions set up accurately. What else? Did anybody else have one that they aren't sure what they did wrong or how they were supposed to do it? Okay, I'm going to stop this video here. So I'll post this video and the one I recorded in my other class that goes over all those other teacher created ones. So you'll have access to those when you're reviewing or if you get stuck doing your corrections.